Good morning. This is lesson 80 in Saxon 8.7, and it's about transformations. So we talked about transformations last year, and you may have heard about them the year before that. So this is a review and taking it one step further because you're in 8th grade. So first, you might remember that if two triangles are the same, or if two shapes, not just triangles, if any two shapes are the same size and shape, they are called congruent. So here on your lesson page, we have two congruent triangles. So they are the same size, they're the same shape. What they are not is in the same position, right? Triangle 1 is upright, triangle 2 is in a different position. So there are three different things that we can do to get triangle 1 into the position that triangle 2 is in. So one is flipping the triangle. And if you look right here, that's what's happening here. So the triangle is originally in this orientation, and then we're flipping it so that it's now in this orientation. So we've done that. The first thing is the flip. So let's go to the next page, draw our flipped triangle here. So we have our flipped triangle. We want to get it into this formation here. So what's the next thing we can do? Well, we can slide it over. So this is considered a slide. So we slide it right up next to that other triangle. So like so. Have something like this. The next thing we can do is to turn or rotate this triangle 90 degrees. Because it's upright, we're rotating it 90 degrees that way. So that will be a turn. So flips, slides, and turns, they're called transformations, right? So the movement is called a flip. The name, the mathematical name of it, is called a reflection, right? Because if you're flipping something, it's like you're showing the mirror image. So a flip equals a reflection. I'm just going to put reflect. A slide, remember, you're sliding over, is called a translation. So if you think about a slide, you're transporting it somewhere. It's like you're putting it on a truck and it's moving. It's a translation, like transportation. So it's a translation. Remember, it's like it's moving on a truck. Turn. Turn is the movement, but the mathematical term for it is a rotation, right? If you're turning, it's rotating. It's a fairly easy one to remember. A turn is called a rotation. So, problems you are going to see. One of them is using a coordinate grid. So, right down here, a reflection has occurred. So these triangles here, we would say that it has been reflected across the y-axis. Because remember, the y-axis is the axis that goes up and down. It's vertical. So here we can see triangle ABC has been reflected across the y-axis. Now, we could also say that it has been reflected and then it's been slid. It's been put on a truck. It's been translated. Translation, right? So we have a reflection across the y-axis and a translation, a slide. So here we have the same triangle situation going on, right? It's been translated and it's been reflected across the y-axis. Now, here's where things get exciting. What will we call this movement? Well, it's been also reflected, except this time it's from this reflection to this reflection, right? It's a vertical reflection across the x-axis, and it's been slid, right? So it is a reflection and a translation. You can say it either way. You can say that it's been reflected first, or you can say it's been translated first. Either way, it's right. Okay. So, let's take a look at example 1 here. Example 1 says the coordinates of the vertices of triangle RST. Let's get our coordinate plane over here, make it a little bit bigger for us. So it says the coordinates of the vertices of triangle RST are R4, 3. So we go 4, 3. Remember, x-axis always first. So this is point R. Point S is at 4, 1. And point T is at 1, 1. So 1, 1. So there's our triangle. Woohoo. So then it's asking us, it says, draw triangle RST and its reflection in the x-axis, RST. So you can see here that it has R, it's called R prime, S prime, T prime. It's just basically saying it's the same triangle, but it's been put into a different position. So that's how you would write that. Okay. So, wants us to, it says draw RST and its reflection in the x-axis. What are the coordinates of the vertices of R prime, S prime, T prime? So, we're going to reflect it across the x-axis. So, we want it to be flipped, right? So it needs to be on the other side. So if we flip it, this would be point S, right? We really have to think about it in our minds, okay? So the triangle's here, and it's being flipped across the x-axis. So this point here is going to be point S. And then this point here will be point R. And this point here will be point T. It is very important that you name these points when you are drawing out the triangle, because I don't know what point you're talking about otherwise. So, that is showing a reflection across the x-axis. Let's go to the next one. A translation slides a figure to a new position without turning or flipping the figure. If we translate quadrilateral KJLM 6 units to the right and 6 units down, we're not flipping it, it's just moving. So it's going 6 units to the right, as you can see here. It moves 6 to the right, and then it's being moved 2 units down. All right. Go on to the next one. Rotation. Remember that rotation is just turning, right? That's a rotation. So, example 3 shows us what a turning situation would look like. So, the coordinates of the vertices of triangle PQR are P, 3, 4. So, we're going 3, up 4. That's point P. It's important that we write it this way. We follow what they tell us. Q, 3, 1. 3, up 1. There's Q. And R, 1, 1. So there's our triangle. PQR. PQR. It says draw a triangle PQR and also its image, P prime, Q prime, R prime, after a counterclockwise rotation of 90 degrees about the origin. What are the coordinates of the vertices of PQR? Now, when we're talking about the origin here, let's remember that the origin, let me make sure I'm correct here. Yes, the origin is 0. 0, 0 on the coordinate graph. There it is. So we're going to rotate it counterclockwise, right? So on my screen, we're going this way. We're rotating it 90 degrees counterclockwise. So again, we really have to think in our heads here. What's happening? What's going on? So we're going to take this over to the next page with us. Save to clipboard. I'm going to paste it here. Okay. So we have triangle PQR still, and we're rotating it 90 degrees around the origin, which is 0, 0, the direct middle of the coordinate plane of this graph. So if we rotate it all the way around, this would be point R, right? So we're rotating it 90 degrees. R over on the other triangle was 2 units away from Q, right? So Q would be 1, 2, right here. Q. And then we know that P was 3 up from Q, right? So we'd go 1, 2, 3. And there's the rotation of our triangle across the origin. So remember, the reason why it isn't right here, okay? The reason why we're not just rotating it like on R, or from the point R, like just straight over, is because it's saying rotate it across, you know, either on the other problems it might say across the y-axis, across the x-axis, over the origin. So the whole triangle has to be over that point, over that axis. That's why we're not just turning it to where it's like, you know, going halfway over this, over the y-axis. So that's why. So if it says over, it means the full triangle needs to be over that axis. Okay. It is now time for the lesson practice, excuse me. Today is going to be Review Tuesday. So remember, we're not doing the mixed practice of the lesson, but we'll do some of the lesson practice. So these are the ones. I'm going to delete this image there. These are the ones that I would like you to try. You will need the coordinate grid pulled up for this one on a Jamboard that I will share with you. So, I would like you to complete B and C. Pause this video, come back when you're ready. Okay, welcome back. So, the first illustration here is B. The second one is the answer to C. So, a brief explanation of why this is. So, for problem B, it says that it wants a 90 degrees clockwise. Remember, it's important to remember which way clockwise would turn and which way counterclockwise would turn. So, it wants a 90 degree clockwise rotation about the origin. Remember that the origin is the very center of the coordinate grid. That would be right smack dab in the middle. So remember, if it's saying that it wants it to be rotated 90 degrees around the origin, that it's going to be over the x-axis and in that, basically in this quadrant of the coordinate plane. So once you had rotated it, you would get point W prime, right? Because we're saying it's the same shape, but it's moved. That's just what that prime putting a little dash above that letter means. So W prime would be 3, -1. X prime would be 1, -4. Y prime would be 1, -1. And Z prime would be 3, -1. So it should look something like that. Or it should look like that is what I need to say. C. Problem C. We have triangle JKL. And it is asking for reflection across the y-axis. So if we remember, it needs to be completely over the y-axis. So when we reflect it, we would get J prime being -1, -1, K prime being -3, -2, and L prime being -1, -3. You are now ready to complete your review questions and move on. Best of luck.